All right, we are getting started again on the object file binary file deep dive. Before I get into it, here's your usual reminder that this project is funded by people like you who check this out and think that it's cool and worthwhile and decide that they can afford to support on a monthly or yearly basis. And you can also just support for a month and withdraw if that's all you can afford. I understand. There's also the option if you can't spare money or you just want to, check things out before you invest or something. You can just go sign up for the newsletter over here on the main page, and that's free. And then you can get announcements from the lab once or twice a month. Plus, podcasts get announced there early and stuff like that. So, yeah, check that stuff out. And thanks for being a part of the lab if you do. So today, we are transitioning. We've been doing executables and DLLs for a couple of weeks now, like 2 or 3 weeks. We've been generating them and dumping. Before that, we were dumping object files and executables DLLs. So now that the executable DLL dumping is pretty much, or generating is pretty much there, it's time to start generating object files. So this is a different game. It's a totally different ball of wax. Let's start with getting our mini.obj into good shape. So, this right here should be, let's see, mini asm. Let's simplify down to something like now remind me, I have the ABI written here somewhere. Malayek says help, although they use 2 L's, so I think it's a hello. Do you need help? Are you okay? Let's see here. What are the... Not prologue, epilogue, stack usage. I'm looking for... I figured. Well, hello. Where are... Hey, Young Lane, welcome. Where are my register... I thought I had this in the ABI section. Windows ABI. Just x64 ABI conventions. How is this not at the top of the list? Here we go. Yep. Yep. How far down do I have to scroll to find it? Here we go. RAX. Return value. First integer RCX. Second integer RDX. Okay. RCX is going to be... whoops. Let's do mov RAX 0. So we could also do... I think it's like XOR RAX, something like that. And then that gives us a 0 there. And then what we do is we do, I don't want to write something complicated. I don't know what I was thinking. Mov RCX into RAX, add RDX into RAX, and then return RAX. There's our plan. We're going to sum 2 integers. And so let's build mini-asm. And you see this is -c. We want to get rid of that. This is -c, which is how we get mini.obj. So our goal today is to start with a quick look at mini.obj, because we're going to start trying to generate one of those. And if we can succeed, what we'll do is we'll end up putting generated.obj through the linker to create a program. And let's see, we're not going to need this part for now. But we're not there yet. We haven't gotten to the point where we can generate an OBJ. Yes, please. All right, so it's a nice and tiny little file here. A nice tiny little file. And this is what we're going to try to recreate. So mini OBJ, you can see this is very different from something like mini.exe, which starts off with the MZ and the DOS header thing and all this, and then we get PE, and then we get architecture here. This one, the first thing we get is machine number of sections. Where do we get? Yeah, here we got architecture type, number of sections. This one just starts off right there. Boom, boom. Time, date, stamp, pointer to symbol table. There's no magic. There's no magic at all, actually. COFF. Let's see here. The section table. So the virtual sizes are empty. What is 140? It's 8C. $147. 9.3. So these are not aligned to anything. That's just an odd byte that got dropped on, right? .debug %s 1 2 3 4 5 6 7 8, and then here it is. Symbol table. String table. It's empty. It's an empty string table. Okay. All right. So there's our target. Now, the first hard thing about this is that so much of what I've built already, there is one other thing. The text section here, we said 140 starts at 8C. There's our text section. Copy. Copy as C array. So this is like mob rax rcx. This right here is like add rax rdx, and this right here is like ret. Okay, so the thing here is like all of this is structured appropriately for creating a PE file, not a COFF file. So we kind of got to figure out now where that is and is not appropriate. For one thing, I should probably have centralized this already. Generated.obj. But even more than that, I gotta start thinking of like this. So yeah, some of these I don't know. Like, are we gonna do exports from an OBJ file? Maybe. I feel like we would have to at some point. But I also don't know. I gotta start figuring this out. So there are some things that are image only. So we're not gonna have a DOS header. We're not gonna have a PE signature. We're not gonna have the optional header. We're gonna have a COFF header and a section table. But things like the export directory and import directory are part of the optional header, so none of that's going to exist. So it just feels like some of this can't be the same. We never did generating for load config either. Or for TLS. Definitely want to get back and do those. But let's see here. Alright, we don't need unwind info right now. We don't need a jump. We don't even need an entry point. We do need to modify this. This is like that now for some reason, right? Don't exactly know what that stands for, but that's what it does. There's just an empty data section for some reason. We'll ignore that. And a debug section, we'll ignore that. Pascal Bayer, yeah. I know that the linker is gonna strip off all the things that come after the $sign and combine them. So I know, like, if we have multiple .text $sign sections, all of the $signs and everything after the $signs gets removed, and the text sections get linked together into one text section. I'm aware of that. I just don't really know what MN stands for. But yeah, they do that, and they sort alphabetically the whatever was past the text section. They take that part, or past the $sign. They take that, use that to sort alphabetically the little sections from the object files. So none of this needs to happen. This doesn't need to happen. Like, everything I'm doing here is just out. Even this right here all of this is unnecessary as well, because this goes into the optional header that COFF files don't have. So all of this is PE specific as well. So we almost ended up with nothing except our basic block system, like our data block system. I shouldn't say basic block. We're a little too close to compilers to be so sloppy with language about that. Now this one, I think in theory, if we had unwind info, it would actually need to stay in the object file. So I'm gonna keep that around. That's even more critical than these. These are useful features, but this is like correctness. All right, let's see. What I need to do is replace this part. Okay. Oh man. Yeah, this is gross. We need to think about this API again. We need to. Oh man, there's a lot to do. This is a lot. Okay. This is uncovering a whole different dimension of this. We're in sloppy territory today. Okay. We're gonna slop it up. We're gonna get all disorganized with it. Okay. Headers has to get rewritten. We'll pass over that. Let's do that first. Let's pass over this. So no DOS header, no PE signature. Here's our COFF header. Machine type AMD64 is the very first thing. Yeah, that makes sense. Section count, optional header size. timestamp for 4 bytes. Symbol table f off. Symbol count. So this has to stop being empty now. Symbol table was empty for PE. It is not empty now, so this will be new. One sec. All right. Optional headers after symbol count. Two bytes. Yeah, that's a 0. Cool. Gotta make sure I'm making changes in the right location here. Yeah, this is big file. This should not be getting changed. This one should be getting changed. Okay. Okay, we need to fill those in. Yeah, so what are the flags supposed to be? Characteristics. Looks like they are all 0s. Okay, so there's our COFF header. There's no optional header. There's no data directories. There is a section table. This has to be different. Okay. So there's our headers. This part has to be different. right, so there's our COFF header, and then we get sections. I just skipped this song. All right, so text section, execute, read. Yeah, good deal. Okay. So let's see, after the section table comes down, in the headers, what do you do next? You finish headers and you do sections. Okay. So let's drop off our sections. Okay, that part needs to change too. Hey Tool, welcome back. How are you doing? Man, I devoured my coffee today. I'm gonna go get more. One sec. Okay, so it should be bogus, but I should have a generated OBJ file now. Yes, use a COFF parser. All right. And it doesn't like it. There's, yeah. Invalidity. Lots of invalidity in this. Okay. So to get started, we've got an agreement. Let's look at the diff between. We're gonna take these little steps at a time. So let's see. What are we disagreeing on right there? That's the timestamp. We don't care about disagreement there. What about this? What is this a disagreement on? Symbol table. Okay. So there's a few things to work on here. We could try to get the symbol tables in. We could try to get the string table in. And let's see. In order to even get this thing up and running, I think we need symbol table, string table, and we need to fix the layout thing. So let's start with the layout thing. So there are two ways we could do this. We're being sloppy today. Let me just lay out the options here. Usually I would do this with a whiteboard or a notepad, but today I'll do it with my voice. And if you all want to see what I'm picturing at some point, I'll stop and do Milton, but we'll see. So the problem is that all of the layout stuff so far has been written to assume that we have these virtual alignments and file alignments for the PE style layout. But the object file, the binary files have a different layout pattern than the object files. The object files don't have a voff space at all. Object files are only file layout. The virtual layout is not applied until the linker designs the virtual layout to create the binary file. So the voffs would just always be 0 if it was done correctly. So this is irrelevant. The entry point is irrelevant. Image-based vadder is irrelevant. All of this is stuff that we end up having in binary files. So one idea I have two main ideas, right? There's this layout stuff is all relevant to binary layouts. And we could just say, like, look, this is like, it's time to do a COFF layout and make this our PE layout, right? And then we'll just have two different ones. But there's a question of, like, how much of it is going to be very similar code between those two. If we look at what we do with the layout when we add a section, this part is all the same, right? For our COFF file, we'll just always put a 0 here. We'll put the flags are the same, the name's the same, the block is the same, the layout could be the same. It's going to be even more of a pain that we have to know the section count up ahead of time. So we'll have to think about if there's any way to fix that. The rule for updating voff cursor and foff cursor will change because we'll no longer care about virtual alignment and file alignment. So the layout rules will be different here, but a lot of it can be the same. This would all be the same. This would be the same, although we might want a different rule here, and we would want to make sure this is always a 0. How does layout get initialized up here? Starts at headers size plus virtual align. Headers size would have to be calculated differently. So it seems to me like we do have to basically say when we create a layout, if this is a PE layout or a COFF layout, we are creating two different types of layouts there, right? Like I'm basically picturing we need this. We need the idea that there is such a thing as a PE layout and there is such a thing as a COFF layout. And so we'll have some way of saying like a PE layout new constructs one of these from scratch. COFF layout new constructs one of these from scratch. But then a PE layout or a COFF layout, they are both equally just a layout. And so the rest of our API is written like this: layout and let's say section info and block becomes a new layout. And this works the same whether we created a PE layout or a COFF layout. The finalize thing is annoying. There's like a PE layout, a final layout, and then to bake. So that is not the same between these two. We could just fold this into this if we wanted. Or rather, we could take these two and wrap them to make these more like this. In which case, we actually have layout to file again, right, as an option. So what are we doing here? So all of this, right, this is super abstract notation. What I'm basically saying here is we could create two types. We would want some way to create an API that doesn't look like two types, but really the only thing that they have in common, the only reason I want that is because they have in common this ability to add sections, which is a significant amount of code to have to apply twice. And then there are these set things. Each of these is only for the PE type, actually. So we once again have like PE layout and label to a PE layout, right? There's all these things that are specific to the PE layout. So another way of saying this is this. We could just say there's such a thing as a layout and they each contain a layout, and then we could do it the object-oriented way. Don't really like to do it that way. So here's the deal. There's label. There's these setters here that are PE layout specific. PE layout itself has this finalization step. COFF doesn't need that. There's a way we could abstract it all and make it all layout all the way through. The way that would, you know, you can see if we did separate types, the abstraction is that these two agree on what this part means. So now, the object-oriented way to solve this is to say we've got a layout, and then say we've got a PE layout, which starts with a layout and then does more, right? And a COFF layout, which starts with a layout and then does more. But then I hate that. That's really annoying to work with. What we would end up with is like PE gen layout add section gen, and then you'd have like your, you know, COFF layout arrow layout. Like you'd do something like this to get this to the parameter there that is generic, and then, you know, you got your name and flags and, you know, the block or whatever, right? You'd have this sort of pattern, right? The other way we could do it is the Lego brick method. So the Lego brick method says we take all of this and we stick it in there, and we take all of this and we stick it in there, right? We just have a layout all the way through, and now layouts are just layouts. We will probably end up having to say like what kind of layout we're dealing with right at the beginning, and then all the shared stuff goes here, and PE specific stuff, or like binary specific stuff, COFF specific or object file specific stuff, if there is any. And then finally, one other thing we're ignoring here is there might be COFF layout specific stuff too, like, you know, symbol table. So if we were to do it this way, what we would do to represent this is to say, okay, we're saying PE layout equals layout, COFF layout equals layout. So we're doing a substitution to simplify the API. So we end up with this, and this, and this, and this. This, of course, is trivial now. These all say layout. This says layout. Okay, this right here the final layout contains stuff that we calculate about the layout when it's done. I think we could just put this, I think we could just fold all of that into the baker for now. This, and this we could track as we're going. This we could track as we're going. I mean, all of these are calculated by a loop over the sections that goes in order. So literally all of them could be incremental. None of them require like a double loop or anything more complex, a single pass over each element. This one goes backwards right now, so it's a little bit more efficient if we do it at the end because we don't have to look at every single one. So yeah, then in the end we just want layout to file. This is also layout to file, and as we see we can collapse that to just a layout to file function. So having applied that substitution, it simplifies down to this. I think this is the right way to do it. I think feeling it out, we'll do it that way. So let's take some baby steps here. Layout final is going to be different. All of this is going to go away, and we are going to say goodbye to layout finalize. It's not really going to be missed because I never loved that in anyways. Instead, what's going to happen is everything that was done in finalize is just going to be done incrementally during add section. If the new section v size is greater than 0, then the image size equals the new section's v off plus the new section's v size. I'll round it up. And we stick that right there. Okay, so that helps us incrementally figure out all of those values instead of calculating them at the end. What did we miss? Okay, here we're just grabbing these straight out of layout now. So you're out and you're out, which, hey, that gets us one step closer to making these identical. Bakefile and bakefile COFF are still different function calls, but when we are done, they won't need to be. Let's go back to generating an exe real quick. Okay, we're crashing. Probably we don't know the correct size. Let's see. I can't quite tell, but probably all of these are currently empty. Like, are we... I guess it's set up to import something right now. Let's say we actually don't want any imports. What am I doing on time? It's been an hour. This feels like the right spot to take a 5-minute break. Alrighty, be back in a minute. Well, 5. All right. Bum, bum, bum. Crashing. So we are gonna now switch over to Remedy because I don't really know what's going on. Yeah, just run it. Block 0. Okay. Got it. Okay. Directory table. Okay, so no R data, none of that. So now the question is, if we look at our layout, perfect. Paging Turner asks a very on-point question. Does this mean that layout is the union of all the data that is needed to support every feature of every file format? So to answer that part, basically yes. I wouldn't say it's the union exactly, but you're thinking about it the right way. The difference is like if I have a union, right? If I have like let's see, how do I want to do this? Let's say I've got my layout, and then I've got like shared data, right? And then I've got union, and then there's like PE layout, PE, COFF layout, COFF, right? And then there's like a kind right here. It tells us if we're the PE or COFF kind. What I'm doing that's a little bit different is I'm just doing this. I'm not even making the union. I'm putting all of the features in there all the time. And the reason for that is because, well, first of all, this is a little bit misleading. What actually tends to happen is that this is like, you know, a bunch of fields with names and stuff. And over time, it'll turn out like, okay, in some cases I'm using 3 of these. Sometimes this ends up actually being relevant here. So which things are shared, which things are PE only, which things are COFF only, tend to be lines that blur and they overlap in complex ways. So sorting it ahead of time, it turns out to waste time. So the only difference between what I'm doing in a union is that I'm not even bothered. A union is like compression, right? Like, oh, we don't want unused fields sitting around. But this isn't, we don't have an array of 1,000 layouts to iterate over quickly. We're building one of these things right now, so just like put all the fields in there. Don't worry about compressing it. The advantage to that is flexibility, and then yes, what'll happen is you'll have a couple different approaches to how you could use it. So if you set up a layout up front, you're going to need to tell it what kind of layout you're creating, even though they're all the same type, because what kind of layout you're creating determines how the incremental layout is going to work. Now, I might need to get off of the incremental layout anyways to solve this problem where I have to know the number of sections up front. So as I try to solve this, and as I try to simplify, it might turn out that we can do a layout that is completely unaware of what kind of layout it is, and that it's only like, you know, it might be an API like this. You create a layout. You've got stuff for modifying that layout. You've got stuff for setting things inside the layout. Some of these might be COFF only, some of them might be PE only, but they're all available all the time. And then there'll be it'll be like that, right? So it might be that we could defer figuring out the file kind until the very last step. And that would be cool because then that means you can build all of this. You can write this code, and if you're switching back and forth between an object file and an exe, it doesn't change very much, right? Like the code for one works for the other as well, which would be nice. However, I don't know that that's a very useful goal. There's going to be a lot of differences. Like if we start generating the machine code, for instance, you just, whether you're an object file or an executable, makes a very big difference about how you actually think about what you generate there. So if we start doing like, right now we're focusing on the layout of the sections, the layout of the extra, you know, relocation data, the debug data, all that kind of stuff. If we were going to start doing something more like an assembler in our own code, if we're going to start assembling instructions in our code, then what you do here is a little different for exe versus object files, so it might not make sense to worry too much about making the abstractions of these things perfectly clean. I don't really know yet. But I do think the flexibility for now makes it much easier for me to just get everything working side by side as I'm experimenting and learning. Okay. So now I can generate a generated exe like that. And the reason I was doing that was because I wanted to make sure it still worked. Now, turn that back off. Set this back to being like this. Set this back to being like this. And run it again. Okay, that works. Got a generated OBJ. We can't parse it. But we want to go and modify the layout rules now. So right now, I am going to have to tell it whether we're doing a layout for a binary or for an object. I don't like this. Let's do this instead. Because I want most of it to be the same. So this is what we do. If the kind is a binary, okay. If we're an object file, we don't do a DOS header. This is missing one. PE signature. We don't do that over here though. We do COFF header, no optional header, no data directory, section header, section count, and then we don't do an alignment. Okay, so Yeah. Crap. Okay. See what we get. There. So now the layout, it's still not parsing as valid because we're missing the string table and symbol table. We'll get there. When we diff these, we're just agreeing on the number of sections. We're just agreeing on the timestamp. We don't have a pointer to our symbol table or a number of symbols, which we should have. We agree on the size of the optional table. For the optional header, here we've got text mn agrees with this. Virtual size is 0. Virtual address is 0. Raw size, pointer to data. We've placed it at a slightly different location because we don't have all the same data. No relocations. No line numbers. No relocations or line numbers. Contains code. Alignment 32. We're missing that part. And mem read, mem execute. So alignment 32. Okay, so that's the pointer that's different. 2, 8. 2, 8. No, that's not the pointer that's different. That's... Oh, that's 3, 8. Yeah, 2, 8 is the pointer that's different. Here, we agree here. We don't agree right there. You're giving me a 5, which says alignment 32, but I've got a 6. Interesting. Okay, so my documentation here tells me that a 6 is an alignment of 32. This is telling me an alignment of 32. Well, maybe that's not an alignment of 32. Let me see something real quick. Section table, characteristics, alignment has a value of 32. I don't understand. Why does it say alignment 32? Oh, do you know what it's doing? We've got a byte. If these are the low, if this right here is the low bit and this is the high bit, so here we've got high, here we've got low, right? Then the high 4 bits, that's what these are. These are the high 4 bits. When you put a 1 there, you get an alignment of 1, and it looks like, well, let's see. There's our 1, 2, 4, 8. Here's our 16 position, right? So this right here is worth 16. 1, 2, 4, 8, 16. So this right here is worth 32. So it's telling me I've got a 1 right here. So that's a 2 right here. Right, if it's telling me the value is 32, I think what's happening is that it's reading those high bits and saying, hey, this byte looks like a 32. That's the only way that it makes sense, right? It's a 50. Well, no, it could be that it's a 50. Why would it interpret that as a 32? A 5 would look like this, right? No, no, no. A 5 would look like this. How is that 32? I don't understand why it says 32. That's the thing. That's why I'm confused. I think it's trying to say this, right? I think it's giving me an alignment of 16. Yeah, their alignment code is wrong. Should be like this. There we go. So the alignment value they're calculating was just calculated wrong because according to the docs, a 1 means 1 byte, not a 0. So it's all off by 1. Okay. Okay. Yes, reload it. Run the diff. There's our pointer. Our flags now match. So what is this? 3C? These disagree because I don't have any more sections, and it does. Okay. So I think the interesting part to focus on, though, is going to be this. Pointer to symbol table. Let's go and look. This is an foff, the file offset of the COFF symbol table. And the question is, so that's 256, 100 in hex. That's this right here. Is it a part of a section? That's what I want to know. Section table. Does one of our sections have an... So that starts at 140. We're looking, and it goes for 7 bytes. 147. 0. It starts at 147, goes for 108 bytes. $255. So this pointer to symbol table points here, which is past the end of that debug section where there's even more stuff. So none of this is in a section. This is just extra stuff outside of the sections. That's very different from the image file, which puts everything into a section so far. So interesting. Interesting. Let's see. So let's start with, we want to generate our symbol table and link it in, and then we want to place it into the file, and finally we want to see it get rendered and pointed at by the generated object. Okay. So the layout, what happened here? Oh, this isn't the right file. The layout So we can set our symbol table, and then we need to be able to use it. We don't need this anymore. We need to be able to use it. First of all, let's go and make one. Okay, symbol table. Let's talk about what goes into a symbol table before we go any further. Tell me about the symbol table. Okay, we also have pe.h symbol table, right? Don't we have COFF symbol records? Okay. We have names for 8 bytes, values, section numbers, types, a storage class 882. So this must be, do we have a pragma pack? We do. Okay. So I think the name can be any length. But if this part is 0, then this is an F off to the actual name. Okay. The signed integer that indicates the section. Type storage class. Okay. This says it's an offset into the string table, not just an F off. Let's see about that. 3, 4, 5, 6, 7. So that fits in the string. There's our value, section number, type, storage class, number of aux symbols. Fits in 8 again. Fits in 8 again. Fits in 8 again. Fits in 8 again. Okay, so in order to see it, I'm going to do this. Build mini.obj again. Yes, I would like to reload it. I'd like to rerun the parse. And so now we have debug here. And so here, our name says 0's here and 4 there. So yeah, that is an offset into the string table, not an F off. That's good to know. Okay, so a symbol table is going to be made up of symbol records, maybe just symbols, which are each going to need a name, I'm not entirely sure. I think we're going to need this. Except section number isn't quite what we need. We need to know a label, I think. Something like this. All right. All right. I think that'll work. I'm a little unsure. I think symbol tables might need more attention than what I'm giving them right now. We're going to kind of just do a first pass symbol table and maybe think about revisiting this tomorrow. Or not tomorrow. That reminds me, tomorrow, if you do join me for my stream tomorrow, we are not going to be doing this project. We're going to be switching over to 4Coder Fridays for the first time ever. Well, for the first time in this new 4Coder Friday series. You know, I used to do 4Coder Fridays back when I was working on 4Coder actively. I'd very often make Friday my day to do a little 4Coder streaming. And I've decided that it would be very fun, possibly informative, maybe even useful, and certainly cathartic for me to go back and read some 4Coder code and talk about it. Because my style has evolved a lot since the day I started 4Coder, right? 4Coder began in December of 2014. We are coming up on 10 years since I started 4Coder. And there's a lot of stuff that still lives in the 4Coder code base that is very different from how I program now. And so reviewing it and talking about what I learned from those mistakes and why I would do it differently, I feel like it'll be fun and useful. So, yeah, check this out tomorrow. We'll be doing 4Coder Friday. And who knows where that project will go. Sometimes I think I might end up writing a new text editor or a new kind of editor with text editing built in. Sometimes I think I might jump back in and make some changes to 4Coder again. I got a couple bug fixes I might be interested in. Who knows? Who knows? Let's see. I'm not convinced that that'll work for every symbol type, but that'll work for now. Okay. Okay. Mercine says, I'd be very interested in a comparison stream between how you write code nowadays versus then. Well, that's basically exactly what I'm doing tomorrow. I'm going to be looking at the code, and I'm going to be going, hey, this is... I see what I was trying to do, but here's how I would do it now, and why I think this is better. And I'm going to just go through as much of the code as I can before I get bored. Maybe I will actually rewrite some of it. Maybe we'll make a new editor. Maybe we'll just end up rewriting every single piece. I don't really know what the vibe is going to be. But that's basically what you described is the rough idea. It's what I want to do. So either catch it live tomorrow, 10:30 a.m. Pacific time, or you also can, if you don't know, I have an archive YouTube channel where everything I ever stream can be found. Symbol, what are we talking about here? Storage class, that's what we're looking for. What's our storage class? So if I have this guy, what's our section number 1? Storage type. Yeah, this thing's all confused. This thing doesn't really know about types properly. Storage class external 2? Yeah, cool. So we're doing storage class external type. Yeah. Type function. And boom. What am I missing? Oh, position. You need the position, right? Some position. So there we go. I think that's where we'll stop for today. We've sketched out a loose constructor. We still need to be able to bake this, and we still need to be able to generate front into, or place into layout, something like that. We also need to actually, we have to do the string table in parallel with that, so we need a little bit more there. Yeah, so we're not done, but that's where we're leaving off. We're going to keep up with this goal tomorrow and work on all of that. Once that's done, I think we'll be able to generate an object file completely. I'm not carrying on now, even though we're kind of close, because I have a deadline. I have to be off stream in the next couple minutes, so we are unfortunately out of time for this one. But yeah, next week, tomorrow for Coder Friday, starting Monday, we'll work more on this. Maybe I'll do this off stream too. I might already get this done. I might get this done before then, but we'll see. Either I'll do this on stream or we'll start from somewhere a little farther along on the object file generator. But as far as what we've done today that has worked out, we've managed to redo the layout system, or refactor the layout system a good amount. There's still a lot here that I think is crufty. There's a need for a real pass over the layout system. We want to get off of this, like, stop declaring section count up front. We want to get off of simplify and clean up. Well, we already got rid of final. Yeah, I guess there might be. some opportunities there for cleanup. Okay, I think that's a good stopping point. As always, I'll give you a couple of reminders. I've already talked about the schedule. If you like these projects, you like the 4-Coder Friday stuff, or you like the object file, binary file work I'm doing, or the YouTube stuff, I've got new arena content coming out for the blog soon. I've got more stuff about linkers and object files and C programming coming out on YouTube within the next 4 to 6 weeks, probably. The videos take a little while, but if you like any of that stuff and you would like to help keep it going, I do count on supporters to come to mrforth.com/membership and sign up. You can do it once and then cancel, or you could do it every month. You could do it on a yearly basis, and there's a lot of cool perks. And you could also, don't forget, go sign up for the newsletter if you just want to get the free public announcements when they come out. And later this month, keep in mind, we've got the Handmade Network doing the Wheel Reinvention Jam from the 23rd to the 29th. So I'll be participating in that on stream during those days instead of my usual projects. And on the 20th, if you join me in the afternoon, I will talk about my project ideas and we'll decide on what sort of prep for the jam. So that's what we've got going on this month. So yeah, to repeat for someone who's asking in the chat, my schedule is I stream at 10:30 a.m. on weekdays. So tomorrow, Friday, for 4-Coder Friday, 10:30 a.m. Pacific time. So put that in and figure out what time that'll be if you want to catch it live. That'll be 4-Coder Friday tomorrow, and that'll also be my time of the day every Monday through Friday, unless I'm taking a day off for, recharging or scheduling or something. I think that's everything. So with that, thanks for coming and hanging out, and I'll see y'all around the internet. Bye.